Alright, this is the screencast for section 4.6 on graphs of composite trig functions. Composite functions meaning a function within a function plus a function times a function. We are composing trig functions into various forms that you haven't seen yet. Now, a lot of the graphing for this section I have done ahead of time, so feel free to pause and see if you can get the same graph on your calculator, but at this point we've had a lot of experience with our calculators that I don't think it is necessary for me to show you all of that process. Alright, example 1, combining the sine function with x squared. So example 1 has a, b, c, and d where they have added x squared, multiplied by x squared. They have composed the sine function into x squared, and then they have composed x squared into sine. So I have graphed each of these ahead of time, and we are going, and I've used the window negative 2 pi to 2 pi. My change in x has been pi over 4. And I adjusted the vertical window sometimes, and we're going to see which functions appear to be periodic. Part A, this function is not periodic. It is also not parabolic, so don't confuse those two. That is not a parabola. It is not the same on the right as it is on the left. You can see it's a little bit flatter over here. So this is not periodic. B is an odd function, but it is not periodic. It is not repeating itself. Now I understand there is more graph here, so you never really know if it's repeating itself, but because the instructions told us to graph from negative 2 pi to 2 pi, we can assume that we would have seen the repetition within that window. So this is odd, but not periodic. Part C. This is clearly periodic, and actually the period on this function is pi. It is not a full 2 pi anymore. This is periodic with period pi. Now you can see the sine function normally would have done something like that. It would have gone up and then swooped down, but this square makes every value positive. Not exactly like an absolute value, but squaring everything will change the y values a little bit, but also makes all of the y values above the x-axis. So now we have a repetition of every pi with that function. D is an even function, and though it does seem like it has some sort of pattern, it is not exactly periodic because it does not repeat itself. There is still a little bit of difference between this loop, and this loop, and this loop, so this is not periodic. It is even, though. The now try problem was problem number 5, x times cosine of x. So I've graphed that here, and we have a very similar problem to example 1b. There is an odd function here, but it is not periodic. So this is odd, but not periodic. So it has odd symmetry. The opposite, the y values are the same, opposite the origin, but it does not repeat itself. Odd is a type of symmetry, periodic is a repetition.